trigonometry review, topic 3. So topic 3 is all about circular functions, circles, triangles, stuff like that. First step, note our basic triangles. So first thing you need to know is SOHCAHTOA, right? This only works for right triangles, but if you have a right triangle, it's supposed to be a right triangle. There we go. This is your angle. We call the angle, the side opposite, naturally. Here's your right angle, 90-degree angle. I'll cross from that is the hypotenuse. And the last one's adjacent next to the angle. So that's all it stands for, right? This is sine, is opposite of hypotenuse. This is cosine. This is tan. Right, so if I give you a little triangle here, like blah, 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 and this is 4, 5, and 3. Now let's say I wanted tan of this thing. I would go, okay, here's my angle, here's opposite, here's adjacent, and tan is TOA, opposite of adjacent, so 4 over 3. And this leads right into unit circle stuff. I mentioned before, I don't care how you do unit circle. There's like 3 different ways you could do it. One way, if you want to memorize the whole circle because you're a mad person, go ahead. I'm going to show you the other 2 ways again, right? So one way is to make a table. Some people complain about making a table because it's like, oh, you have to memorize the whole table. It's really not about memorizing. It's about building. So if you know how to build, it's like kind of Pascal's triangle. If you know how to build it, you're going to be fine. This is a little movie magic. Now let's actually build. So again, if you know how to build it, you're going to be fine. So we start with sine, cosine, tan. Right? And then you always start with 0, then 30, 45, 60, 90. And in radians, it's degrees. It's 0, pi over 6, pi over 4, pi over 3, and pi over 2. So again, the key to this is that first column. So if you know the first column, the rest of it's fine. And it kind of grows up. You start at 0, sine of 0 is 0. And then we just go 1 over 2, 2 over 2, 3 over 2, and then 1. These are radicals. This is actually rad 4 over 2, which is 2 over 2, which is 1. So that's it though. 0, 1, 1 over 2, 2 over 2, rad 3 over 2, 1. These are radicals. If you get that, then the rest is fine. Because all you do here is, okay, switch it. So this is 1, you flip it. Rad 3 over 2, rad 2 over 2, 1/2, and 0. Tan is also known as sine over cosine. So you just put sine over cosine. So 0 over 1 is 0. 1/2 over rad 3, the 2's will cancel out. You get 1 over rad 3. Also known as rad 3 over 3 if you want. Rad 2 over rad 2 is the same. So you get rad 3 over 2 over 1/2. Again, 2's cancel out. You just get rad 3. And then 1 over 0 you cannot do. That's undefined. Right? So if you do the table along with that, you have to know your all students take calculus, I should say. Remember, this tells you where stuff is positive, and A stands for all. So if I was looking like, where is sine positive? Well, it's positive A because all, and then S, that stands for sine, so plus, and then the other 2 has to be negative. So that's the idea. So with this, if I had said, what is cosine of 7 pi over 4? So what you always do, no matter what, is kind of like a graph. You gotta know where it's at. So 0, pi, 2 pi. My trick to graphing is always make this common denominator 4 over 4. So I got to go to 7. So 4, if I go another 4, this is 8 pi over 4. So 7 is a little bit below that right here. So I'm in quadrant 4. That's important for if it's positive or negative. So 7 pi over 4, if you just look at your chart here, over 4, rad 2 over 2. And then based on the chart, all students take calculus. Cosine is positive in that quadrant, so positive rad 2 over 2. That's how you use the chart. Let's do another one real quick. Let's say tan of 2 pi over 3. So write 0, here's pi. 2 pi over 3. Now, again, my trick is always look at the denominator. This is 3 over 3. So we're a little short of that. We haven't reached there yet. We're in quadrant 2. All students take calculus. We're doing tan here. So positive A and then positive at T for tan. So my value here is going to be negative. It's going to be a negative value. Now all I would look for is where's pi over 3 at for tan. Rad 3. So this is a negative rad 3. So that's using a chart, right? Easy, clean, effective, it works well. Right, so that's how you do unit circle using a chart. You just gotta build a chart, but again, the key to building charts is this right there. Once you get that, you're good. Build it on everything you have. The other way I do it is a triangle method. Again, I don't care which way you do. Either way, you have to memorize stuff. Triangle method, you have to know your triangles down pat. Right, you have to know a 30, 60, 90 triangle is 30 small, it gets to 1. Hypotenuse is always 2, this is rad 3. If I do a 30, 60, 90 triangle, look at the 60 triangle angle. 60 is big, it gets to rad 3. Hypotenuse is always 2, so that's a 1. And if I want the 45, 45 triangle, right, it's 45, 45, 90, so these are the same, 1, 1. That hypotenuse is always 2, but in this case it's radical. Right, that's the way it works. You only get one radical. If you notice in the 30, 60, 90, 30 is small, so it gets to 1. Hypotenuse is always 2 in any case. But over here, you have a rad 3. Over here it's 1, 1, so you have the radical 2. Right, hypotenuse is always 2, always. And there's always at least one radical. So how would I do it this way? You have to have those things memorized. Again, you have to have these memorized to be good at this. Otherwise, you can do the chart. But let's say I want to do sine of 7 pi. Let's do sine of 7 pi over 3. 6. Right, so again, 0, 0, 0 pi. Look at the denominator, this is 6 over 6. So we're going to go a little bit past this. We're going to be down here. So 7 pi over 6. No matter what, you have to know what angle that is. 7 pi over 6 is a 30-degree angle. So once you have that, you're like, okay, opposite's 1, hypotenuse is always 2, adjacent's rad 3. Now it's like a normal grid. Here's like your XY chart. You're going to the left, so negative, and you're going down to negative. Sine is SOHCAHTOA. Opposite over hypotenuse, negative 1/2. By the way, if you look at the chart, right, pi over 6, 1/2, and then it's in the bottom left coordinate, so it's negative. Let's do one more. Let's do a tan of 5 pi over 3. 0 pi. So this is 3 over 3. Again, we haven't got there yet, so I'd go around again. 6 pi over 3. And we're a little bit short of that, so we're down here. Now again, if you're doing triangle method, make a little triangle here. Over 3 is automatically 60. 60 is big, so you get the rad 3. Hypotenuse is 2, always. And this is 1. Again, it's normal chart. You went to the right, so positive. And you went down, so negative. I forgot to mention this, hypotenuse is always positive. It's like a radius, so never make that negative. Tan is TOA. Opposite over adjacent. Negative rad 3. Actually, before I go past unit circle, let's do one last example with the quadrantal angle. So let's say I want sine of pi. So how do you do that with the chart? Well, you have to know where sine of pi is. So pi is over here. This is 0. Here's pi. So pi is on this side. So anytime it's not one of these, you gotta like add a negative to it. So in this case, it's on the opposite side of pi of 0. So it's this one. So it's negative 0 or just 0. That's how you do it with the chart. If you're doing it about triangles, you have to memorize that this is like a normal grid. You went to the left one, unit circle. So negative 1, 0. And then sine E, sine is a y value. Cosine x. So 0. Right, let's do another one. Let's do sine, this because it's more fun. Sine of 3 pi over 2. Right, so again, on the chart, how do you do it? There's no 3 pi over 2. You gotta know where that's at. If you draw it, here's 0, here's pi. We usually don't deal with these two. This is pi over 2, halfway. This is 3 pi over 2, halfway between that and 2 pi. So we do have 2 pi, and for us, sine of 2 pi is 1. So in this case, it's on the opposite end, so you make it negative. So it's a negative 1. So that's how you do with the chart. With the triangles, against memorization, you went down 1. So this is 0, negative 1. Sine E, so negative 1. So that's a unit circle. You have to know that. You're going to use so much. We're going to use it in this video and use the next video a lot. Okay, but after that, let's move on to some easier stuff. Like first, law of sines. This is pointless. So this is what they give me in the formula sheet. A over sine of A equals B over sine of B equals C over sine of C. I don't know why I forgot to put that there. And then it's just proportions. So the key thing about law of sines, you use it when you have a pair, right? So what do we mean by a pair? Like I say right here, a side and its opposite angle. So let's just look at this first. I'll draw two triangles up here. 60, 30. Let's make that 50. Let's make this 4. And then X. And let's do this. 120, 4, and 5. So first thing, if you ever get a triangle problem, label the sides. So it doesn't matter what you label them really. It does matter for law of cosines. I'll mention that in a bit. But so label it something like this. Here's B. Here's a side opposite. So lowercase b. Here's A. Side opposite. Lowercase a. C. Lowercase c. Now for law of sines, you need a pair. And look at this problem here. I have a pair. I have the B's. So I can use law of sines. So I'm just going to go follow the formula. 4 over sine of 50 equals, we're trying to find A, X, the side, over sine of 60. Cross multiply and be done. Or multiply by sine 60 and be done with this problem. Keep in mind in this case, right, if you notice I didn't draw them, I meant I should have degree signs. If you see a degree sign, change your calculator degrees. Radians should be default. But when you switch from radians, when you see a degree sign. So radians should always be default. When you switch to degrees, when you see a degree sign. So that's how I'd solve this one. And by the way, you can switch this to be like that, but it's the same formula. It works either way. This one over here, if you look at this one, I have no pairs. Here's my angle. The side opposite, I have no idea what it is. Here's the side, angle opposite, no idea what it is. Here's a side, angle opposite, no idea. So you can't use law of sines on this one. So that's when we use law of cosines. Right, so law of cosines is good when you have no pairs, right? So if you have pair, law of sines, otherwise law of cosines. We have two formulas. This one's a little easier if you're looking for the sides. This one's a little easier if you're looking for the angle. Now the key thing about this is whatever make whatever you're looking for C. It just makes your life so much easier because these formulas are set up. These are what's giving you a formula sheet. Just set up for C. So let me give you an example. I might do PKM. They like doing variables like that, and they'll say this is 4, this is 5, and this is 6. The question would be find smallest angle. So first thing I do, I'm going to relabel this with the smallest angle as C. Because again, make what you're looking for C. So the smallest angle here, guys, if you're not sure, it's always across from the smallest side. Like they match. The largest angle would be K, because it's opposite the largest side. The smallest angle would be H, because it's opposite the smallest side. Smallest angle would be M, I should have said. Anyway, so this is the smallest side. So I'll make this my C, my little c. And then other sides don't even matter. Let's say A and A. And let's say B and B. So I can use the formula, right? Again, I'm looking for an angle in this case. That's what I'm looking for. So I'm going to use this formula. So cosine. You can put M, because that's what it really is. Right? Just try and flat match the formula. Equals A squared, which in this case would be 6, plus B squared, which in this case would be 5 squared, minus C squared, which is 4 squared, all over 2 times 6 times 5. Now you can put this in your calculator. I have one right here. So the way this works, again, there's a couple ways to do this. Easiest way is to do alpha y equals, whoa. Right, just type it in, 6 squared minus 5 squared plus 5 squared. Oh, I hate when I make a mistake. Minus 4 squared all over 2 times 6 times 5. Right? The reason I did the like this, so I don't have to worry about putting parentheses everywhere to make sure that fits. Because otherwise, you need parentheses around the bottom, parentheses around the top. So I get that. So cosine m equals 3/4, so 0.75. Now remember the way you solve this. So I did cosine m equals 0.75. Now the way we get rid of the cosine, do cosine inverse on both sides. Again, it should be in degrees. I'm pretty sure my calculator right now is in radians. You get credit either way though. So if I did it right now, I'm pretty sure I'm in radians. Second cosine of the answer. I get that, which is a rate. See, like it doesn't make sense. It's a radian degree. If I switch it to degrees, I go back and select my cosine inverse. I get 41.410 degrees. I get 41.409, 3 sig figs, 41.4 degrees. Right, so that's law of sines and law of cosines. Key thing to keep in mind with law of cosines, right? Make whatever you're looking for C, just makes it easier. Right, and then how do you know which one you use? If you have a pair, law of sines. Otherwise, law of cosines. Let's look over some other odds and ends dealing with triangles. So like this one, lines in 2D space. So a line that passes through the x-axis and forms some angle degree with positive x-axis, the slope given by this. So they want you to find m. Well, we should know this. The trick here is this right there. They might not even tell you the tan part. They say find the slope. The trick is, if you make a triangle out of it, this is 30 degrees right there, right? This is your y value. This is your x value. So slope is always this tan of the angle. That's the key thing to keep in mind. So if you have a triangle here, right? That's y, that's x, that's tan. Opposite of adjacent. Should have said that earlier. Right? But that's why it's tan. It's opposite of adjacent. There's no hypotenuse. So in this case, if I figure out what the angle is, I do tan of 30. Right? I don't care how you do it. I know tan 30 is, oh, this is 1, because opposite 30, rad 3, and 2. So my tan of 30 is going to be 1 over rad 3. So that's what the slope of that thing is. The slope is 1 over rad 3. By the way, it's a little preview for vectors. Keep in mind, slope is y over x, right? Just like we showed right there. They might ask you to, hey, put this in a vector form. If you remember your vectors are like this, x, y. So I want to put this in vector form. I got to keep in mind that vectors go x on top, y on the bottom. Slope is y on top, x on the bottom. So I got to switch it to this. So that's how you write that in vector form. Let's move on. Triangles, right? Area of a triangle, right? This is the one we've been learning since grade school. We're not going to give you that in IB. Well, they do give it to you, but they're not going to ask that. This is the key one to memorize. Oh, it's actually in a formula sheet. Tell them to memorize it. 1/2 AB sine C. Now, the key thing about this is A and B are just sides, right? Lowercase. And C is the angle in between. I don't know what that's supposed to be, an arrow. Whatever. Angle in between. Angle in between. Right? So that's a huge thing to keep in mind. It's two sides of the angle between. People always just kind of pick any two sides of an angle. Don't hurt me. It's two sides of the angle between. So like this, perfect example. You want to find the area? Here's your side. Here's the side. Hey, I have the angle between. So let's go area equals 1/2. 7, 12, sine of 120. Put that in your calculator, make sure in degrees. You get your answer, right? Again, it has to be two sides of the angle in between. This formula only works when you have a height. And a height has to be, height is a right angle, always. Right? Think of that. Has to be that to be height. So I went up to my things up here. If I want, I got my angle now. 41.4, actually 41.4. So I can find the area. I have this side and I have this side. Area could be done. Right, same thing over here. Once I find out my x, actually I could do 180 minus to find this, but then I could do area. I can find my area of this one. Two sides in between. Right, that's how I find area. By the way, up here, if I really want to, I could use the basic, because I have a base and I have a height. Area. If I want here, base and height. Area is 12 divided by 2. So anyway, that's the idea with that. So let's go over some practice problems. So I gotta find this angle here. Now again, notice a lot of people are like, "Oh, it's sine cosine." This is not a right angle. They don't give you a right angle. Can't tell. So you have to use law of sines and cosines only. Look what happens here. Do I have any pairs? I have my angle here and I have that. That is not a pair because I don't know what that is. So no pairs equals law of cosines. So log cosines, I'm looking for an angle, so I use this one. Right, now all we gotta do is label, like to label my sides. The thing you're looking for is always your C. It's little c, the rest don't matter. You just plug it in. So this would be, this is cosine C, sorry. Ooh, that's an ugly formula. Should just copied it. Ooh, that's disgusting. Anyway, so cosine x, we pass it for Grosso, equals a squared. A squared is 6, so 6 squared plus 7 squared minus 5 squared all over at the squared. It's part of the 5. All over 2 times 6 times 7. Right, put in your calculator, get an answer. Right, cosine x would equal something. Cosine inverse both sides. That's how you get rid of cosine. Sitting on that side, and you get x equals some number, which I really don't care about right now. Next one, right? Same idea. Look at it. You're like, oh, no pairs. So log cosines. Right, because I have this angle and that side, but I don't have that side. Now in this case, I have a side I'm missing. So you can use the same formula, but on this one, the side one's a lot easier if you just look for them. It literally has a side missing. So c squared equals a squared plus b squared minus 2ab cosine c. Right, so this is a lot easier. Again, both on your formula sheet. This one's a lot easier if you have sides. So it just has a side you're missing right there. So label your sides. The thing you're always missing is your c, and the other two don't matter. So in this case, I have x squared equals a, so 10 squared plus 7 squared minus 2, 10 times 7, cosine of 45. Now with this, just plug this all into your calculator, right? There's no variables there. Just plug it all into your calculator. And you get x squared equals some number, square root it. Next one. So in this case, if you look at, I have an angle. Hey, I have a pair. Woo. So in this one, we're gonna do our formula. So a over sine of b, sine of a, equals b over sine of b. It's in your formula sheet. C over sine of c. Now the key thing here, guys, it's sine of c. Sine of c. Sometimes people just drop out the sine part. They just put the angle there. It's sine of a. Why did I keep on saying c? Anyway, sine of a. So here, in my case, again, it doesn't really matter what the letterals are. It's the side 12 over sine of 23. Biggest mistake, people just put 23 down there. It irritates me. You can't tell. Over here, right, this pair, the side's up top, so 21 over sine of x. Same idea, I'm going to solve for sine of x, so I'm going to do a little cross multiplication here. 12 sine of x equals 21 times sine of 23. Divide by 12. I get sine of x equals some number, and then sine inverse both sides. Arc sine of both sides, same thing. There you go. Right, that's how you solve triangles using law sines, law cosines, right? All calculator stuff for the most part. So let's go on to a little bit chord and tangent stuff. First, some basic rules. If you might have forgotten from geometry, if you have a center with two radiuses, so these are radiuses. Remember, radiuses are always the same measurement because they're radiuses. And there's a chord here. And then if this thing's a 90-degree angle, I'm writing all over it. That means these are the same. That's a fancy way of saying that if you see this, then these two sides are the same, right? If you have two radiuses, it's cut in half, then these sides are also equal. And they're similar triangles. They're actually identical triangles. Here's a bigger one. If you have a center with the radius that makes a with a tangent line, right? So you know something's tangent to it. They tell you, hey, this is tangent, and it touches your radius. Then that has to be 90 degrees. It has to be. So radius plus tangent equals a 90-degree angle. It's perpendicular, we call that, or orthogonal. So that's how I deal with this. So that's what we see this here, right? You go, okay, I have this. Oh, it's a radius. That means it's a tangent, or they tell you it's a tangent line, so you know it's 90 degrees. Same thing here. It's a radius, they tell you it's a tangent line, so you know it's 90 degrees. Which means you can use all the 90-degree stuff, law of sines, law of cosines, SOHCAHTOA, all that good stuff, because you know it's 90. Let's do a quick example. So here they want me to find the x. So I have the x right there. what I want to do is, oh, here's a radius. I can make this a radius also. So that's 6. I know this is already a tangent line, so that makes that a 90-degree angle. I can do the same thing on this side. I can connect these two things is the more important part, though. So I go like this. Oh, it's my attempt to connect these two things, but I can't use that. Let's erase. Let's do it again. So again, I can connect these two things. There we go. Right, now if you see there's a triangle right there. So it looks kind of like this. I'm going to butcher it again, obviously. This is 6, this is a right angle, that's 10. Now, x is the whole thing, so I'm going to do this. I'm going to make this a y. And I can figure out what y is. Look at it, it's a right triangle. I can use all the right triangle rules. And the key one you want to use here is, what are the sides? Opposite, adjacent, is that hypotenuse? Opposite adjacent is TOA. So tan of y equals opposite of adjacent, 6 over 10. You want to find out what y is? Do tan inverse to both sides. Then y would equal, I believe, like 30 degrees. 31 degrees. So this is 30 degrees, which make this also 30 degrees, which x is 2 times that, so around 60. Now it's a little rounded off, but that's a general idea, right? It's all about using right triangles and your SOHCAHTOA. Next one here looks like a doozy. And given the figure AB equals 1, so this side right here is 1. AC is 3, so this is 3. They want to find the radius of the circle, so I gotta find what this is. It's R. Now here's the thing. How are we gonna do this? Well, that's R. Look at this. This is also R. If I know that's 1, like, so first there's a triangle here, right? Let's not beat around the bush. We all know there's a triangle there. Right? This is R, this is 3. I guess I gotta figure out what that is so I can solve this thing. Well, that's 1. And this is also radius. This is also R. So this is gonna be R minus 1. That's the right triangle. Now the way you solve a right triangle, Pythagorean theorem, a squared plus b squared equals c squared. So r minus 1 squared plus 3 squared equals r squared. You can do some math. Now here's the key thing, guys. This, don't be lazy. It's not r squared minus 1. It's r minus 1 times r minus 1, which is r squared minus 2r plus 1 plus 3 plus 9 plus r squared. Do some math. You're going to get r equals 5. So this is actually 4, 3, and 5. So, right, that's how you solve it. Again, keep in mind, this should be an equal sign. R squared minus 1 is not r squared minus 1 like that. That doesn't work when there's a plus or minus there. You got to separate it. Every time there's a power with a plus or minus, binomial theorem in there, separate it. The next one, the angle subtended by the chord BC at the center of the circle. That just means they want this angle, which is this angle. So that's a right triangle because we had a little right triangle right there. So solve it any way you want. I'm a little partial to sine. So sine is opposite of hypotenuse. So sine theta equals 3 over 5. Do sine inverse to both sides and get our answer. Okay, last thing we're going to talk about in this video. Sectors and arc length. So this is straight from your formula sheet, right? If you want to find the arc length of something, it's this r times theta. So that's the arc length, right? If you want to figure out how long is it from here to here, you just multiply. Let's say this is 20, and this is 5. You just go, okay. Oh, actually not okay. All these are in radians. Keep that in mind. So these formulas are both in radians. So in this case, theta is 20, r is 5. I can't just plug it in there. I got to make sure this is in radians. So the way you go from degrees to radians is you multiply it. You multiply your degree by pi over 180. So how do I keep that in mind? I just remember, this is not your formula sheet. I just remember that I want radians have pi in it, so pi is on top. Right? If I was going the other way around, the pi would be on the bottom. But you want radian, you want degrees, so pi is on top. So this will just be 20 over 20 times pi over 180 equals 20 pi over 180. You can reduce that, but times that by your radius 5, and you get your arc length. Alright, so keep in mind, if we're trying to find arc length or area of a sector, your angle has to be in radians. Very, very important. The formula is only in radians, and it matters. So in this case, at 20, I had to convert it first, and then just multiply by 5. So with that in mind, let's look at this problem. find the area of triangle OAB. So they want me to find the area of this triangle here. Now remember, the area of a triangle, 1/2 AB sine C. So for A here, we're going to do 1/2 AB sine C. Now keep in mind this is a triangle, and it's actually a circle too, right? So this is a radius. So if that's 12, this is 12. So it's going to be 1/2 12 12 sine of 110. Put that in your calculator, get a number. Now look at B. Area sector OAB. So they want sector OAB. So that's this whole sector. The whole little thing there. So sector OAB. So area of a sector is right there. So area equals 1/2 theta r squared. So remember, theta has to be in radians. So I have a degree right now. I got to convert that. So that's going to be 110 times pi over 180. So it's going to be 1/2 110 pi over 180. I put all my calculator times 12 squared. And then C, find the area of the shaded region. So if you look at the shaded region right here, well, what is that? It's the whole sector minus the triangle. That's how we find these. Anytime you want to find a funky shaded region right there, you just do the whole sector minus the triangle. So it's going to be the area of the sector we just found, which is that, minus the area of the triangle we found earlier, which is this right here. That minus that, you get your answer, and we are done with this part.